let's move on. So there was a situation here which we can resolve whichever way. Perhaps, the right choice would be to make this public, right? If someone really wants to call this with integers, maybe then the right choice is to, not to confuse people like this, but really change this private to public and allow them to make a call directly. So there you go. Next, protected, we'll discuss protected later on. Protected is when we start using class inheritance. Protected is just another version of private, but with some additional rules. It's just a third version of public, private, and protected, to be discussed later on. I often add these lines to our slides so that if you want to use it as a reference later on, you will come back and you can read all 4 of them and not just 3 of them, because we're not covering protected right now. So moving on. Access control example, I guess this is what we already did. And so we have a class named point, and we have a private function named reset coordinates, and there's also public functions distance to origin, okay, whatever that is. So we're going to in point.cpp, we're going to define distance to origin as square root. So we include the math header, and there's a square root that wants to take double parameters. The double parameter. So basically, we essentially multiply. We essentially compute the distance to the origin by doing this computation and then taking square root, right? So this is a very typical way of computing distances on the plane, right? When you have a 2D plane and you have to compute the distances to some place. And the origin here is assumed to be 0, 0, right? So we just say, okay, you have this x coordinate and y coordinate, so that's just, this is how far away from the origin we are. So, okay, so we have this implementation, and distance is a public member function. Then we say main is a free function, not a member function. Instantiate point, attempt to assign 4 to mx is a no-no because it's private, so this will not compile. Reset coordinates is not going to work because it's also private, and distance to origin will be okay. So just very basic examples here. Member access includes members of other objects to our includes members of other objects of our class. I guess what we're trying to demonstrate here is this new function. We say distance to another point. So this is actually an interesting example. Let's make sure that we're we try it out. Okay, so right here. Oh, this is a player. So right here, I will just go and kind of copy and paste, my favorite operation, I guess. Right, and then in the implementation file, we'll just do the same thing. Well, you know what? No. 1 second. Control Z. Okay. This. We'll keep this. Control Z. I'll just keep what we have and only go ahead and add this particular brand new distance to point. Okay. So now I'm adding brand new function right here, declaring it, distance to point, and using its declaration such that it will take point other. This is a typo. It should be matching this, right? So let me just let's put it all together. Okay, and this will be the function that we need to define. We declared it here. Now we have to define it. So somewhere here we need to say double, I guess just this, right? Distance to point, and use point. Make sure that the compiler knows what we're doing here. So here's the situation. So distance to point. The idea is this. I now create, let's name it point 1. Okay, and then we'll create point 2, right? Point 2, and initialize both with like set, you know, this may be 5 and 3, whatever, right? So now I have 2 objects, so I create them, and now I can say point 2, tell me what is the distance to point 1. You know, how far are you from point 1? Okay, and use a double result, right? Or I can say dist, right? The distance. Distance equals this. Okay, right? So pretty legit idea is like, okay, points should be able to communicate in terms of, you know, this is very useful idea. Like compute the distance between the 2 points. I could rewrite this differently by doing this. This should produce pretty much the same result. Like I could say, okay, point 1, tell me what is your distance to point 2. Those should be pretty much coming back with the same kind of result. All right. So the implementation again would be to say maybe is that we have to access, we have to take it. Well, I guess let me just take it step by step. Inside this function, I can say what is the difference in coordinates. Double difference in coordinate x is, well, of course, I have my own x right here. You know, I was called on, say, point 1 or point 2. Then this is the instance member variable which belongs to the object on which the call took place. So if I might try this, right? So when I say right here pt2 call distance to point, this x is part of pt2, right? But pt1 right here is passed as a parameter, right? So this becomes this other. So pt1 is passed as other point to this function, distance to this other point. So then I can say x minus other dot x. So I do have access to both instances, and regardless to the fact that they're all, I'm forgetting that we're recording it, right? So regardless of the fact that the member function was invoked, but 2 objects also are involved, the current one on which the call took place, and also the other one which is being involved in computation, still it's completely okay to access private member variables inside a member function, such as distance to point, and you can say, okay, the difference in coordinates x minus other x, right? So x is Rx. So essentially, again, we could bring up this. So if for example, we had, so this was point 1 and this was point 2, what happens is that this function of distance to point was invoked for this guy right here. And this is x, and this is other, right? And this is other x. So it's perfectly okay to compute the difference, right? And come up with the difference right here and name it diff x. So there's no problem doing it. Similarly, of course, you just say, okay, what is the difference in coordinates between, y's right here? So, of course, the result can be positive or negative, but the good thing is that all we have to do is return square root of them multiplied, and that's just the formula to compute differences, so I kind of misnamed those guys. So this should be this, and this should be this, and this should be diff y and diff y in my version. Okay, so anyway, square root also is not known, so obviously I have to either say include CMath over here, or maybe if I'm going to be doing this, elsewhere, I mean, there's nothing wrong actually doing it right here in the point.h file and then include point h. Doesn't matter. Maybe this will be better. It's your call. You can do it either way, right? So I'll just include CMath, which brings square root into the scope by including it inside my own header, and just include this point so that it gets included indirectly. So let's see if it works.